Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. We are currently in the process of learning about a popular decentralized finance application called Uniswap. So far, in this course, we have learned about Uniswap theoretically. In this lesson, we will navigate the app. While the theory behind Uniswap sounds complex, there are broadly only two processes that are occurring on the app. The first process is liquidity provision by liquidity providers. The second process is token swaps by traders. We will begin this lesson with a demo of liquidity provision. We are on the Uniswap desktop app. I will now navigate to the tab called Pool and add a new liquidity pool in the capacity of a liquidity provider. I am prompted to select a token pair. I select USDT, which is the symbol of the stablecoin Tether. I deposited 0.001 tokens of Ether. Note the app automatically shows us the quantity of Tether based on their current price. Next, we will reflect on a few items we see here. First, we can see the field for fees tier. The recommended fees tier for Ether and Tether pair is 30 basis points. If we selected two stable coins, then the fees tier would have been lower than 30 basis points. If we selected a more volatile token pair, then the fees tier would have been higher than 30 basis points. We learnt earlier that higher volatility means greater impermanent loss. Hence, the fee acts as a compensation for the degree of risk of impermanent loss. Uniswap lets the liquidity provider choose among a finite number of fees tier. Each fee tier corresponds to a unique pool. For instance, there is an Ether Tether pool for 30 basis points and another one for 50 basis points. If a liquidity provider chooses a higher fees tier than warranted for the risk profile of a token pair, she may end up providing liquidity to a pool with low trading volume. Next, we notice are the deposited amounts. Where are these tokens coming from? You can see that the 0.001 Ether was sourced from a balance of 0.018 Tether. Similarly, the source balance of Tether was 4. Where are these amounts sourced from? We can see on the top right quadrant, the source wallet address where the tokens are held. Both my wallet, in this case, the MetaMask wallet, and the Uniswap app, are installed on my desktop. The two apps can communicate with each other. Another notable element of this screen is the ratio of the deposited amounts. The quantity of Tether was automatically selected based on the quantity of Ether. This is derived from the current market price of these two tokens. We can see the relative price of the two tokens on the right. We can see that the ratio of deposited tokens is very close, though not identical to the current price. Another element we can observe is the target price range of the LP. The app is suggesting a certain range based on analysis of recent data. As a liquidity provider, I have the option of changing the range if I so wished. We learned about concentrated liquidity in detail in the previous lesson. Notice that the gray line represents the current market price. I am now back to the Uniswap app. I will preview the liquidity pool that I just created. Everything looks good. Hence, I will add the liquidity pool. Now, we need to wait till the transaction is processed in the system. The outcome of this transaction is the addition of the tokens to the liquidity pool. Now we can view the resulting pool token, which records that I deposited tokens and confers an entitlement to any trading fees. We earlier learnt that the pool token issued by version 3 of Uniswap is non-fungible. Next, we will view some key elements of this non-fungible token. On the left, we see a visual image that is mapped to the NFT. The visual image shows the token pair of Tether and Ether. Next, we will dig deeper into this visual image. Note the token ID 458511 assigned to this NFT. The symbol of Tether is USDT. We can also note that the symbol of Ether is represented by the addition of a W. The W stands for wrapped Ether. Since Uniswap requires both tokens in the pair to conform to the ERC20 standard, the app mints an ERC20 token called wrapped Ether in identical quantities to the amount of Ether deposited. This has no impact on the liquidity provider. It is merely a technical functionality arising from the fact that Ether does not conform to ERC20 standards. So far, we have seen the front end of Uniswap. But what happens behind the scenes on the Ethereum blockchain? Next, we will explore the underlying transactions on the Etherscan Block Explorer. I am now back to the Uniswap app. I am going to click on the icon on the upper right. This is my MetaMask wallet, which is linked to the Uniswap app. As we discussed previously, the tokens which I deposited were sourced from this wallet address. I will now scroll to the transaction history and click on the deposited tokens transaction. This brings me to Etherscan. On Etherscan, the first thing to note is the Ethereum address from which the deposit token transaction was initiated. This is my externally owned account, whose private key is held within MetaMask. However, you may remember that I initiated this transaction from the Uniswap app and not the MetaMask wallet. This was possible because the two apps, Uniswap and MetaMask, are integrated. The destination of the transaction was a smart contract address of Uniswap. The name of the address is Positions NFT. This contract mints the non-fungible pool tokens issued to liquidity providers. Next, we will see what occurred behind the scenes when the transaction reached this contract address. Two categories of events occurred when the transaction reached the contract address. The first category relates to ERC20 tokens. The second category relates to ERC721 tokens. Next, we will look at the ERC20 tokens first. Initially, Ether is transferred from my Ethereum address to the NFT Positions address. The NFT Positions smart contract then issues new wrapped Ether tokens of equal amount. These are replicas of the Ether tokens but follow ERC20 standards. This is purely an internal technical requirement of the Uniswap smart contract and has no impact to the liquidity provider. These wrapped Ether tokens are then transferred to the ownership of a separate contract address, which maintains the liquidity pool. The other token in the token pair is Tether. Since Tether is by design an ERC20 token, no equivalent of the wrapped Ether exists here. The Uniswap NFT Positions contract simply transfers the Tether tokens to the smart contract address of the liquidity pool. Next, we will visualize this via a diagram. A transaction was sent from my Ethereum address to Uniswap NFT Positions address. On the Tether side, it is very simple. Ownership of Tether tokens were transferred from my Ethereum address to the Uniswap v3 liquidity pool address. The Ether side is a bit more complex. Next, we will graphically visualize the Ether side. The ownership of Ether first transferred from the liquidity provider's Ethereum address to the Uniswap NFT Positions address. The Uniswap NFT Positions address then mints wrapped Ether tokens that were ERC20 replica of the Ether received. The wrapped Ether tokens are then transferred to the liquidity pool contract address. Next, we go back to Etherscan to review the ERC721 side of things. The ERC721 standard relates to non-fungible tokens. We can see that a new token was minted and assigned to the Ethereum address of the liquidity provider. The token ID 458511 is the ID that we saw on the Uniswap app front end. We can now go back to the Uniswap app a few days after I deposited the tokens into the liquidity pool. The total value of my liquidity pool in US dollars is 3.34. Of this, 41% is in Ether and 59% in Tether. At the time I made the deposit, the equivalent dollar values of the token were exactly 50-50. This is because liquidity providers contribute to the token at market price, but over time the tokens get used up in trades within their pricing range. At this point, you may be wondering what is the position of the two tokens in the global liquidity pool across all price ranges. Next, we will take a look at that. I click on the Pools tab and then click on Top Pools. Let us give this a minute for the pools to pull up. The pool I am interested in is Tether and Ether. As I mentioned previously, a pool is a combination of a token pair and a chosen fee tier. Here, I click on the 30 basis points one. We can see that the pool has about 27 million Tether and 21,000 Ether. The price at which an incremental token will trade in this pool is reflected here. 1 Ether trades for 1.86,000 Tether. Next, I will confirm this by processing a swap. Let me go back to the Uniswap app. I am next going to click on the Swap tab. Next, I will swap tokens in the role of a trader. I select some Ether from my MetaMask wallet. This is my input. I choose my output as USDT. We can now confirm that the marginal trade is occurring at 1.86. This leads us to a question. In the global Ether Tether pool, there were 27 million Tether and 21,000 Ether. The ratio is about 1,309 Tether per Ether. But the price of the marginal trade price is 1 Ether at 1860 Tether. Why this discrepancy? The reason, as we learnt in the previous lesson, is that in Uniswap version 3, the price curve is really an aggregation of multiple overlapping price curves, which makes the mathematics far more complex. Hence, the current price is not a simple division of the two token reserves. Next, we will look at this reality visually. The total tokens locked in the global pool are distributed across different price ranges. The red line represents current marginal price of Ether from the pool. That is about 1 Ether equal to 1855 USDT. If the price of Ether in centralized exchanges increases above this, traders will like to reach a point to the left. They will be buying Ether from the pool. Let us say the price of 1 Ether increases in external markets to about 4,500. We can see that a very small amount of Ether is locked in this extremely small range represented by the blue line here. The reason is that not many liquidity providers have provided liquidity in this range. It is highly unlikely that the price of Ether will suddenly swing to the extreme. Ether inventory is available to the left of the red line. Tether inventory is available to the right of the red line. This is consistent with what we learned in the previous lessons. So far in this lesson, we have looked at Uniswap from the perspective of the liquidity provider. Next, let us look at it from the trader's perspective. I will now proceed to the Uniswap app and click on the Swap tab. The app can see that my MetaMask wallet has some Ether in it. I now enter a small amount of Ether I want to swap with Tether. I can see that I am getting from the Uniswap pool about 1.80084 Tether. I can see the exchange rate here. Does it make sense for me to make this swap? Next, we will look at this question. However, before we do that, it is worth noting that I can only buy one crypto token by selling another. Uniswap does not let us buy tokens with fiat currency. Hence, one first needs to seed the MetaMask wallet with crypto first. In my case, I had first bought Ether with fiat currency on Coinbase and then transferred them to MetaMask. I am going to record the exchange rate of Ether and Tether I am getting in the liquidity pool. The effective exchange rate I am getting in the pool is 1 Ether equals 1800.84 Tether. Next, I go to Coinbase. I record the price of Ether. Then I record the price of Tether. I can now calculate the Ether-Tether exchange rate in Coinbase. 1 Ether equals $1801.08. 1 Tether equals $1. Hence, 1 Ether 1801.08 Tether. We can now compare what I am getting in a decentralized exchange like Uniswap versus a centralized exchange like Coinbase. Tether is cheaper in Uniswap. Hence, as a trader, I would buy Tether with Ether in Uniswap and sell the Tether I purchased in Coinbase. Note that at the point of swapping, I will also have to consider 3 additional costs that will impact the economics of the trade. These are trading fees, slippage and gas fees. By the time we are doing all this calculation, the prices would have changed in both Uniswap and Coinbase. Hence, professional traders deploy algorithms to do this. They are probably not doing manual comparisons and calculations. Let us go back to Uniswap and this time we will complete the swap process. The prices would have changed by now. I am swapping Ether for Tether. My input is Ether. The trading fees of 30 basis points is calculated on the input. It is deducted behind the scenes and added to the non-fungible tokens of the liquidity providers. The output is Tether. I click on the swap button. Now, I come to another screen which I need to accept for the transaction to go through. Next, we will review the screen. We can see that the Uniswap app is telling us what the expected slippage is compared to the marginal price implied at the point on the curve we are trading. Further, since a transaction in Ethereum takes a few seconds to post, the slippage may increase further. Hence, Uniswap is guaranteeing that if the slippage increased beyond a point, the transaction will become void. Also, we can see the network fees, which is the gas fees paid to miners. The trading fee is embedded within the token exchange rate, similar to how banks embed fees into foreign currency transfers. What we have covered about Uniswap seems quite complex. But at the end of the day, it is really just a simple demand-supply equation. The liquidity providers are providing supply of crypto tokens. Their gain is trading fees. The cost they incur is impermanent loss. The traders are the demand side. Their gain is arbitrage profits. The cost they incur is trading fees and gas fees. This brings us to the end of this demo of Uniswap. In the next lesson, we will make some final reflections on Uniswap.